This lecture is on recursion, and I'm going to show you what recursion is, how we can implement a recursive function. So if you look at it, recursive functions is defined in terms of itself in multiple, instances. For instance, it calls itself. Now, recursive functions are made out of two parts. They're basically two parts made out of the recursive function. Now, the base case, let me get down to basic, which is the smallest instance of the same problem. For instance, here is the base for this code. This is my base case. And then you got the recursive case, and this is the part of the recursive case. So that's basically what recursion is. See, the recursive case, it breaks the original problem into smaller instances of the same problem. So you see, we keep invoking factorial. Now, so the base case has to be defined for some value. Otherwise, this may end up in all kinds of problems. So for instance, I'm going to give you an example, another example, the factorial. I guess that's the most common recursive algorithm there is. I'm going to show you what happens. For instance, the factorial of 5. So if I do this, I'm going to keep my stack. This is a system stack. This is my system stack. So that means that it's not a user defined. So it's a system stack. The way it does, it defines 5 factorial, and 5 factorial is actually 5 times the factorial of 4. It takes this 5 and it pushes it into the stack. So as you can tell, stacks are last in, first out. So 5 goes into the stack. Now it tries to figure out what 4 factorial is. 4 factorial is 4 times the factorial of 3. So it takes the 4 and it goes into the stack. See, that's why we implement stack is last in, first out. Now, so it looks at 3 factorial. Well, what is 3 factorial? It's 3 times the factorial of 2. Well, take the 3 and push it into the stack. See how my stack, that's why they call a stack a dynamic data structure. Now, 2 factorials happens to be 2 times the factorial of 1. So put the 2 here, see? Then you go to 1. 1 factorial is 1 times the factorial of 0. See, so this is our stack. So now, this is where the top of the stack is. Now, you go to the base case, which is 0 factorial, and 0 factorial is defined to be 1. That's the code right here. Since it returns a 1, it's going to take the 1, pop the first element, 1 times 1 is 1. Then it takes this result, multiplied by 2. 2 times 1 is 2. Then it takes the 2 times the 3, which is 2 times 3 is 6. Then it takes the 6 times 4, which is 24. Then it takes 24 times 5, which is 120, and that's what it returns. So this is the recursive call. So if you look at this algorithm that I implemented here, I'm going to pass 5. I want to figure out what the factorial of 5 is. So it comes to this part. Is 5 equal to 0? It's not. So it does the else part. It's going to take 5 times. It's calling the function again. See that? It's going to call the factorial, and this time it's going to pass 4. So n is now 4. So go back through the loop, to the if condition. 4 is not 0, so it comes back here. So this is going to be 4 times. It's calling the function again. And at the meantime, so that's going to be 3. Those values are going to go into the stack. Now we pass a 3. Checks this condition. Is 3 equals 0? No. So it's going to be 3 times the factorial of 2. See, the factorial of 2. So now it passes 2. Is 2 equals 0? It's not. So it's going to take 2 times, and that's going to be factorial of 1. See that? That's factorial of 1. So this time that was 2. So this time it passes 1. When I pass 1, that's not true. So it's 1 times, and this is going to do factorial of 0. See, that's a 0. Now, I pass 0 here. When it checks this one, it checks if n is equal to 0, yes. Returns 1, then it backtracks. See, it's going to return 1, multiplied by 1, that value was on the stack. Then this call here generated this statement here, which returns a 1. So it's going to take 1 times top of the stack, which is 2. Now, this call generated this statement here, which returns a 2. So it's going to take the 2 times top of the stack, which is 6. Now, when we call the factorial of 3, that generated this line, which returned is 6. So it's going to take 6 times top of the stack is 4, that's 24. Then 4 factorial happens to be 4 times, which is the top of the stack, which is 5, that's 120. And therefore it returns that. So this is basically what recursion is. There are other issues with recursion. The code is elegant, short. I can rewrite this as a much more compact code. But thank you for listening to this video.